Okay, this is the video for basically for a volume. Like I just did a really long video for all of the surface area problems. So now there's 3 lessons left, 6, 7, and 8 in chapter 11. I'm probably just going to do another long video because it's all on volume. Good news is volume isn't as time consuming as surface area, so maybe this won't take too long. So first of all, remember we've been doing surface area in the previous video. Surface area is what it takes to cover the outside of a 3D figure. But if you think about that wrapping paper example again, when you lay it out flat, it's still two-dimensional, right? So our units were 2D, so inches squared, feet squared, whatever, for our answer. Volume is how much it takes to fill up the inside, which is measured in 1, 2, 3 dimensions. So our answer for volume problems are always going to be units cubed or to the 3rd power. Okay. So we have a formula for area of a rectangular prism. I'm sorry, not area. Volume of a rectangular prism is simply length times width times height. So once again, we just need to determine which one we're going to use. It really doesn't matter. I'm going to call this length. I'm going to call this one width, and I'll call this one height. And we're just going to plug in. So let me kind of separate in here a little bit. So V equals 17 times 9 times 24, and 17 times 9 times 24 is 3,672 centimeters cubed. Okay, so that's how you do volume of a rectangular prism or cube. They're done the same way. So 2 and 3 are done just like that. Now, just like in the surface area lesson, we jump from rectangular prisms to all other prisms. All right. So capital B stands for, once again, the area of the base. So whatever that shape is, could be a triangle, could be a trapezoid, could be whatever parallelogram, could be a hexagon, whatever. Find that area and multiply by the height, which is the distance between the bases. Okay. So for this first one, we have a triangular prism. So if we think about this formula, capital B for this problem is 1/2 times base times height. Now, that's the height of the base. Okay, we're talking about just the triangle. So if you ignore the 3D shape, I'm just looking at that little triangle on the bottom down there. That's that height. But then we have this other height. That's the height between the bases. I'm going to write HP there, so we know that that's the height of the prism. Okay, maybe that'll be helpful. All right, so 1/2. Now the base of the triangle. Okay, so let's do it like this. I'm going to trace the triangle that I'm looking at in red. Okay. So there's the triangle. The base of that triangle would be 12, right? It's the same here and here, and then the height is 7.3. So, all right, times 12 times 7.3. All that's in parentheses, and then the height of the prism is this right here. It's the distance between the triangle that's on the bottom and the triangle that's on the top, right? Sort of, it's matching triangle, the other base. Okay. So that's 5. Now, we're not using perimeter at all in this, so that 10 over there is useless. The 9 we're not going to use. We don't need those for this problem. Okay. So I'm just now going to multiply all that together. So I'll start with 1/2 times 12 times 7.3 times 5, and I get that the volume is 219 feet cubed. Okay. 5 and 6 are done the same way. I just want to point out that, I'll show you this, the base here is this triangle, okay, and the height of the prism is the distance between the two triangles, so it's actually 16, okay. So we're not using 6, we're not using 10, because they're not part of the way we find area of the base, and they're not the distance between the two bases, right? So we're not going to use 6 and not going to use 10 in this problem. Okay, for number 6, we have a trapezoidal prism. I'm just going to trace these out again so you can see. So we have trapezoid, this, okay, and then the distance between that trapezoid that's a base and the trapezoid on the other side would be 25 meters, okay, so that we're going to use that for the height of the prism. So that means we are not going to be using, see, 36 is one of our bases, 14 is one of our bases, 17.9 is one of our heights. We're not going to use that 21 for this one, okay. You should be able to do those on your own. 7 and 8, very similar problems. The cylinder problem, okay. We have another formula, pi r squared h. So h is the height, is the distance between the two cylinders. These are really easy to do, so we'll start by writing our formula. So we have 18 squared, and then that's times 15 is my height. Okay, so I'm just going to multiply 18 squared times 15, 4,860 pi. Then I'm going to do times 3.14, and I get 15,260.4 inches cubed. Okay, for this one, the only difference is the radius is going to be 5.5. We're given 11. That's the diameter, so we don't want to use that. Okay, 11 and 12 are sort of some challenge problems. You can see that for number 11, we have a triangular prism, and then it says that there's a cylindrical hole drilled through it. So find the volume of the hole after you, of the whole thing after you subtract the hole that's been drilled through it. So that's just a couple fun little challenge type problems. I'm going to skip ahead. Let's look at pyramids. Okay, so again, the difference in a pyramid and a prism. Pyramids only have one base. Okay, this formula is pretty simple. It's the exact same as any other prism, except for we're going to do 1/3 in front of it. So V is 1/3 base times height. Okay, so again, capital B stands for the area of the base. This one is a rectangle, so 10 times 11 is 110. H is the height of the pyramid, so from the base to this top, I think we call that the apex. So from the base up to the tip top is 16. So I've got 16 times 110, and then divide by 3. So instead of times 1/3, we can just type in divide by 3, and I get 586.7 when I round inches cubed. Okay. Let's see. Number 2 is pretty much the same thing. Okay. For number 3, we're given a slant height, but we don't want slant height for volume. We want the height. Okay. So I'm going to imagine, I'll use this pen. Imagine for a second that we have a right triangle. Okay. So we know that the hypotenuse is 25. This leg would be 7 because it's half of 14. We need to find the other leg. The other leg would be the height of the pyramid. Okay. So I can do 7 squared plus, we'll call that h. H squared equals 25 squared. Okay. So I have 49 plus h squared equals 625. If I subtract 49 from each side, I get h squared equals 576, and then the square root of 576 would be 24. So the height of this pyramid is 24. Okay. After I've done that, it's going to be just like the other one. So 1/3 times capital B times h. Capital B is 14 times 14, which I'm pretty sure is 196, but it's really late, so I'm going to check that. Yeah, it is 196. So 1/3 of 196 times 24. So, sorry, 1568 feet cubed. Okay. Now, let's do one of these triangular pyramids. The only difference with a triangular pyramid is the base is a triangle. So the only difference is the way we find the base, the area of the base. So I would have, you can think of it like this, 1/3. Then here we have a half, base times height. And then I'm going to change this to, again, HP, stands for height of the pyramid. Okay, so 1/3, so 1/2, base and height of the triangle. Now, this is the triangle that's part of the base, so let's try to trace it out. So that base and height would be 12 and 7.5. So times 12 times 7.5. And then the height of the pyramid is 10. Okay. Then you just multiply all these together. Divide by 2, divide by 3, or you could just think of it as divide by 6 if you want to do that. So 10 times 7.5 times 12 is 900 divided by 2 divided by 3 is 150. So the only thing that changed was the way that I found the area of the base. Up here I had at the top, number 1, I had a square, or excuse me, a rectangle. So I just did, length times width to find that. Capital B here, capital B in the formula has to be half base times height because it's the triangle. 5 and 6 are pretty much the same thing. So let's move on to our next formula for cones. Okay. So 1/3 pi r squared h. So pi r squared h we've seen before. That's how you find the volume of a cylinder. The only difference is we have 1/3 at the beginning of these. So V is 1/3 pi r squared h. So that would be 1/3 of pi times the radius is 9, so 9 squared, and the height is 17. Okay. So if I do 9 squared, that's 81 times 17 divided by 3. So I have 459 pi. So 459 times 3.14, that's going to be approximately 1,441.26 yards cubed. Okay. Number 8 is pretty much the same, except for our radius is not 5, our radius is 2.5. Okay. Number 9, the radius, that's 27 is the diameter. So my radius would be half of 27, which is 13.5. That's one thing. The other thing is I need to know the height of the cone. Once again, the Pythagorean theorem will help us out there. So I could do like 13.5 squared plus h squared is equal to 22.5 squared. That'll give me the height of the cone. Then just plug in the radius, square it, times pi, divided by 3, pretty much the same all the way through there. Okay, last one, 11.8. Oh, look, by the way, I understand I'm kind of flying through these. That's for two reasons. Number one, you're just kind of filling out a formula. Number two, you've seen this before. But please, if you have questions or have trouble, feel free to send an email, send a remind, ask a question. I'll be happy to help you if you think I went through this too quickly. Okay, so parts of a sphere. Okay, this arrow is pointing to the dotted line that goes all the way through the center and touches each end of a sphere. Okay, so that would be the diameter of the sphere, just like a circle. Okay, if it starts at the center of the sphere and goes out to the edge, that's called a radius. Okay, once again, the center, I just referenced that. It's equal distance from all I don't know how you say that, all parts of the edge is the edge of the circle, I guess, of the sphere. It's the same distance. And then the great circle is what cuts it in half. It's called a great circle. Cuts it into hemispheres. Excuse me. I told you it was getting late. I totally forgot to tell you what a sphere was. So it's a solid in which each point is equidistant from the center. So imagine a circle, but three-dimensional, okay, aka a ball. So any sort of ball, or like the Earth or whatever, is an example of a sphere. Excuse me. Okay, so volume and surface area formulas are pretty simple. For a sphere, we have volume 4/3 pi r cubed, so it's different, right? Then it's not r squared. We're used to saying radius squared. For surface area, 4 times pi times radius squared. Okay, so we'll do one of each of these. So for the first one, V equals 4/3 pi r cubed. Okay, 4/3 times pi times 7 to the third power. All right, so I ran out of space. I'm going to go up here. So I would have V equals 4/3 times pi 7 to the third power. It's 343. Okay, now let's talk about how to do this. So I've got 343 in my calculator, and I want to multiply it by 4/3. Well, that's the same as multiplying by 4 and then dividing by 3. Times 4 divided by 3. So I just got V is 457.3 pi, and then I'll multiply it times 3.14, and I get about 1436.03. And these are inches, so inches cubed. Right off the page, sorry. Okay, so look at number 2, and how is number 2 different from number 1? They give us diameter, and we only want the radius, so half of diameter. Half of 33 is 16.5, so we're going to use 16.5 for the radius. Okay, 3 and 4 are both surface area problems, so we'll do, let's do number 4. So different formula for surface area. We're going to use this 4 pi r squared. Oops, not V. Surface area is 4 pi r squared. So 4 times pi times 12 squared. We only want half, right? Not 24. 24 is the diameter. So 4 times pi times 144. 4 times 144 is 576. So 576 pi. And then I'll multiply that by 3.14. 1808.64 millimeters cubed. Okay. So far, so good. So now, volume of a hemisphere. So we have different formulas for hemispheres. The volume formula, 2/3. So instead of 4/3 pi r cubed, we have 2/3 pi r cubed, which is exactly half, which makes sense. It's exactly half of the other formula. So I can plug in V equals 2/3 pi r cubed. The radius is 5, so 2/3 times pi times 5 cubed. 5 cubed is 125. Okay, so 2/3 of pi times 125. Now, again, this would mean times 2 divided by 3. So 125 times 2 divided by 3. I got 83.3 repeating, so we'll just round it to that. Pi times 3.14. So I have approximately 261.7 kilometers cubed. Okay, so it's just using a little bit different formula. All right, so last part would be, let's jump to number 7. Okay, so for number 7 we have a surface area problem. That formula is SA equals 3 pi r cubed. 3 pi r cubed. Now, this one is not exactly half, right? For the surface area formula of a sphere, the whole thing was pi r squared. So you're thinking, well, hemisphere is half, so half of that would just be 2 pi r squared. But that's not how it works. It's not 2 pi r squared because when we're looking at a sphere, the entire sphere, we don't have a circle in the middle of it, right? But when we cut a sphere in half, now we have half of the volume, half of the surface area, but then we also just added this flat piece called a circle that wasn't there before. So the formula looks a little different. It's actually 3 pi r squared. I think I wrote cubed. Yeah, that shouldn't be there. That should be squared. Sorry about that. Okay. So 3 times pi times 14 squared. So 3 times pi times 196. And I'll do 196 times 3 is 588. So 588 pi 588 times 3.14 is 1,846.32 yards cubed. Okay. So that's pretty much it. There are some sort of challenge problems down at the bottom that you're welcome to work on if you get bored during the remainder of your Corona vacation and into your summer. Like I said before, and I'll say again, if you have any questions about any of these and want clarification or just need my help working through them, please don't hesitate to send an email or communicate, however you can do that. Good luck in finishing the packet, and hope you guys have a good one, have a good summer, and look forward to seeing you soon.